Yes, I can.
Oh, good. Okay, excellent. I'm sorry. Okay, so it's you have plenty of time. The initial presentation was 15 minutes, but you have more time if you need. So take the time that you need. Thank you, Nicolas.
Sure thing. Yep. Is this live?
Excuse me?
Is this live already?
Yes. So if you share your slide, the windows on which you have your slide, that would be great. Yep. Perfect.
Yeah. Has it been working to do this?
Yeah, you have to go full screen.
Go.
Yeah, that's just perfect.
Great. Well, hello, everyone. Thanks for sticking it out for the rest of the day. Last talk. Sorry we couldn't be here in person. I'm filling in for Cruz Molina, our engineer who's worked on the Tezos integration, if you're familiar with it. I'm Nick DeAndrea. I lead engineering for Truffle Blockchain Group. So for those of you who aren't familiar, Truffle is a development tool around the smart contract development experience. So that means compiling your smart contracts, providing a mechanism for you to write and run automated tests, run deployments. If you were at Matej's demo, he probably gave you the idea. So Truffle started on Ethereum and Ethereum-like chains, and Tezos has been this like an excellent stepping ground to expanding that. And so I'm proud to announce that we're releasing our initial version of Truffle with Tezos support, which I guess you've all already seen. So I wanted to go over some of the features that we've covered. I wasn't going to do another demo, especially because Matej's was so much more comprehensive than mine would have been. But instead, I thought to, I guess, just talk about, well, what does this release include? What is our initial Tezos support? What does it look like? What's included? And to start, well, that's LEGO support. You saw that in the demo today. And what this entails is not only will Truffle talk to the LEGO compiler and pass the files and handle the output, but Truffle also downloads the LEGO compiler, provided you have Docker installed. Truffle has a mechanism for automatically downloading the compiler, because one of the things that we want to provide with Truffle is a user experience that doesn't have a lot of fuss. So we go to Docker Hub, we do the Docker pull for you and get the version, the correct version, hopefully, and get it all set up. So there's no configuration on the user on your part, like as a smart contract developer. And so you can just define a LEGO file and then run Truffle compile, and it'll persist the output for you. Then from there, of course, you might want to deploy to a local sandbox. You might want to deploy to a public test net or mainnet. And so Truffle Migrate provides that. You can configure multiple Tezos networks to connect to, and you take those LEGO contracts that you wrote and compiled, and they'll get deployed to whatever network you choose. And of course, we have to test that our contracts are correct. This is way less exciting a test than Matej had on screen a couple hours ago, but hopefully it gives you the idea if you missed that presentation. This is just kind of taken from the example box, the official Truffle example box, which I think Matej has trumped. But then, of course, you have to interact with your contracts. And so we provide our contract abstraction, which takes the low-level details along with your source and metadata information. And this is thanks to Taquito's help for doing the auto detection and the network communication. But Truffle has a feature where it will detect a contract's interface, like the publicly defined interface for a contract. In this case, that counter has an increment and a decrement. And Truffle's contract abstraction will generate JavaScript methods. And importantly, those JavaScript methods will also take JavaScript data types. And the idea is that this contract abstraction is responsible for encoding those data types, in Tezos' case, into native Michelson, in native Michelson calls, and then emitting the node RPC requests and handling the life cycle of the response and all of that. And so we are releasing these features as kind of initial version. We've tested it. And we hope that this is kind of a good groundwork that we're laying for this integration. I'm really excited about it. Everyone at Truffle is very excited about the direction that this has gone. I guess this is probably all. You've already seen these examples or similar ones on screen. So I wanted to also talk about, I guess, some of the key ideas, maybe to paint a bigger picture about what Truffle's going for. And thinking about it, I broke it out into these, and I guess to go over them, it's a goal of Truffles is to create interfaces and workflows that match the high-level language, so that, because that's what smart contract developers are writing, right? You write your entry points and you define in LEGO the algebraic data types that, like type action, that example that's on LEGO's page. Like, those are the terms that Truffle wants to allow the user to work with, rather than Michelson's pair, nested trees. So that's kind of at the core of it. And Truffle should hide the details by default, but allow access to them. Of course, people need to write Michelson and will continue to need to write Michelson and read Michelson. And so Truffle should also provide access to that, but kind of when you ask for it. And then all of the information that Truffle keeps should be persisted. And this serves two purposes. One, for example, you don't have to recompile your contracts when you migrate. If you did a Truffle compile and you immediately followed it with the Truffle migrate, having persistent information on disk, Truffle just looks it up and says, oh, okay, I don't need to recompile. But it also gives us a place to track all the metadata about the contract, so that, we have the source information from LEGO, so we can feed that to Takedo, which can tell us, oh, these are, this type action is broken out into these entry points, and they match up with the Michelson entry points. I hope I'm not getting too technical, but I'm guessing this is a technical bunch. But beyond that, there's this goal of flexibility, right? Truffle downloads the compiler for you automatically for the languages that we support, but we also provide a mechanism so that you can configure which specific version you want. And so it's like optional default, like optional configuration. You don't need to configure anything, but of course use cases do vary. And so Truffle's an opinionated framework, but we want to give outs, right? You don't always want to be subject to those opinions. And so that's kind of one of the key ideas. Like, well, we'll offer the opinion by default. And we hope it's, we think this is a viable way of doing things, but, please plug in something different. And then beyond all of this, especially moving into this work we've been doing with Tezos, we want to provide this same user experience, right? We have this history of supporting Ethereum, and the Ethereum community has been very supportive and provided a lot of feedback over the past 4 or 5 years of the project, and refined it for Ethereum's use cases. But on Tezos, it's a different architecture, different languages. And so the direction that we see Truffle going is to provide all of these key ideas, right? Like sensible defaults, high-level abstractions, but do it in a way where it's the same experience no matter what blockchain you're on, so there's no cognitive dissonance, if that makes sense. So anyway, the Truffle Tezos integration is a lot of glue code, really. Like we interface with the LEGO compiler, and Gabriel from LEGO has been enormously helpful in getting that set up. That was one of the first things we did. And then Jay and Simone on Takedo, Matage's work. Matage got the sandbox, Flex Test the sandbox working by default in his Truffle box, and we took it for the default Truffle example box that we give you, and that's it's so much better than waiting at the time for Babylon Net, like to mine or to bake, excuse me. And of course, to Tocqueville Group, TQ, and the Tezos Foundation for the support that the financial support that has enabled this. This is a project that we've been very excited about, and being able to make it happen has just been an absolutely incredible experience. And to the Tezos community at large, you are an incredible community. Your early feedback on our releases, the Alpha Tez series, it's just been incredible. It's been enormously helpful in helping us to guide this support and this integration. So thank you all very much. Anyway, here are instructions if you want to install Truffle. One more, there we go. I'll leave this on screen. If anyone has any questions, please, I got at least 4 minutes, possibly more. Well, I guess this was supposed to start.
Questions? No. Oh, yes, one.
Let's ask. Okay. One of your key ideas was to have a similar user experience on different blockchains, which is a good thing. So there are some things which are very different on Ethereum and Tezos, notably how you call other contracts. So in Ethereum, you can call other contracts during contract execution, whereas on Tezos, you have to do it in continuation passing style. So these two things are quite different. So my question is, do you have some kind of abstractions in mind which would kind of unite these two approaches? Is that even something that you would wish to do? And secondly, a more open question, do you think it might be possible to use the Truffle suite to reuse work that has been done for Ethereum? So reuse smart contracts and dApps and deploy them on Tezos.
So I'll answer that one first. There was a project to convert Solidity to Michelson or to Lego, one of those a couple months ago. If there was any progress made on that, then it could be viable to take whatever the source language is there and expect some kind of interoperability, although I don't imagine it would be totally seamless, but viable certainly, or potentially viable. And then you bring up a good point about the continuation passing style, and I must admit that's not a specific distinction that we've looked at, mostly because we're kind of fortunate that Truffle's abstractions don't extend that far. The Truffle contract abstraction is just the operation, not the individual transactions. So I don't think we have to worry about that. I mean, there's analysis tooling that's been built on top of Truffle for Ethereum that just wouldn't work. Any tooling that does go that deep and look at the internal transactions, the calls that contracts are making to each other. That seems like something to keep in mind, though, because I could see, for instance, Truffle has a lot of features. Truffle has a Solidity debugger. If we wanted a Lego debugger, we would have to handle the vastly different way that Michelson works in that case. Does that answer your question?
Yes, it does. And I also think that maybe it's a good thing that your abstraction does not extend so far, because maybe the programmer should be aware of the fact that inter-contract calls are not the same in Tezos and Ethereum.
Yeah.
Maybe. I'm not sure, but...
Well, you scared me for a second there with that question. I'm like, oh, wow, that's significant.
Not a trap or something. Just,
no. It's a big distinction, right? Yeah, but people use Truffle for things that would expect things to work a certain way. So it seems like this is a question that will be asked again in the future for, some specific reason.
Okay, one more question. Yes.
This is sort of piggybacking on that question, and so from what I understand in Ethereum, you have events in the contract, but you don't have those in Tezos, though I can imagine there's a way to sort of recreate that. Is that something that's supported in Truffle or something you would be concerned about?
That is not currently supported because there's just no equivalent in Michelson. To be honest, there's, I guess, 3 or 4, right? And I don't know the most current status like with Carthage, but my list has been views, like read-only methods, contract constructors, and that's a language constraint, not a Michelson constraint. And then events, logs. And it seems like views are starting to be more well understood. Constructors, I think, are solvable entirely just as a language concern. And then events, I don't think until there is a solution for some kind of logging, I don't see a way to implement that for Tezos in Truffle. But you guys make a lot of protocol upgrades, so I would not be surprised if it's forthcoming.
I mean, I think you could sort of recreate it off chain. So you could use an indexer and sort of evaluate the operations that are occurring. Whether or not you want to do that, I don't know. But that would be how it would work in my mind without some sort of protocol change.
Yeah.
Just something.
I like that. Yeah, I like that kind of solution. Like, I was thinking about that. Something I've noticed in the difference just in the community mindsets is that Truffle's gotten away with having expensive gas cost for things like storing migrations on chain all this time. And all the Tezos developers that we talked to were like, why are you doing that? That's not how we do things here. And so it's like, it's opened my mind a little bit to like, okay, maybe constructors can just be a totally different mechanism or views could be entirely off chain, but just a compiler feature. I don't know. So yeah, you could do it with events and have a storage. Yeah. I think if there's something viable there, that maybe by that point when there's a best practice, then that could be added to Truffle, maybe as a configurable way if it's not a standard. Yeah, definitely something to think about. Thanks for mentioning that.
Yeah, thank you.
For events, it's kinda, I have one proposal because we have same problem. We have no complete solution right now, but one of mode of transpiler which we want to implement is simple. You have some proxy smart contract which just accept some message which simply it's same fields which is in event. So you can write these events, but no one library knows that this is event. So you can write it, but you can read it only when somebody would implement support for that. So it's kind of stub for now if you want events, but it's not standardized, and we are open to discussion because we have the same problem.
And this your solution requires like watching the blockchain for these transactions. I guess the advantage of Ethereum's events over that would just be like, this is the way that you could do it, right, with any blockchain. But if the node could support subscription endpoints or filtering endpoints, then I think that might reduce a lot of burden. Of course, tooling could solve that problem. It doesn't have to be in the node. Yeah, feel free to reach out. I don't know if you caught my email, but I'm happy to discuss this or anything else. And I'll, if you're on the Tezos Dev Slack, I'm there.
So if Tezos node doesn't support listen, you can write your own tool which can process all block with RPC and look for some event. So it's kind of similar result, but much difficult because it's not standardized.
Yep. Yeah. That's the thing, right? It's just, it would be convenient for that sort of thing to be standardized. Although I'm not the biggest fan of the way that Ethereum does that filtering, I think. But that's a different talk, I suppose, a technical minutia, I suppose. Yeah, totally viable.
Okay. Any more question? Yes, one more here.
Sorry, another question. So your analyzer for Ethereum contracts, could you tell us a little bit about that and whether you have any plans to extend it to the Tezos ecosystem?
Yeah, so which analyzer, I guess, are you talking about?
You mentioned an analyzer previously, so I guess it's some kind of static analysis or...
We have a Solidity debugger. It's a trace analyzer, and we also have a Solidity decoder library. And I would love for them to support more languages and more architectures than Solidity and EVM. I can go into details if you're curious. Yeah, our debugger is a trace analyzer, so the Ethereum JS or the Ethereum node JSON RPC exposes an endpoint that gives you a list of all of the operations that the machine performs, and then the Solidity compiler outputs source mapping, which we use to translate the step instructions back to their original source locations, and then we use our decoding library, which understands the allocation strategy that Solidity uses for all of its data types, and we use that to get the values, at runtime, at the time of where you're stepping in the trace. This is a challenging piece of software to port to more than one of a thing.
Okay, thanks.
Okay, more questions? Yeah, sure. Yes, Nicola.
Oh, I was just going to say that this is something that's been on the roadmap, right? Like when we are like working on the decoder and our debugger, we've kind of looked at opportunities, but it's probably not on the next, like it wouldn't be a soon thing, right? There's a lot of groundwork that would need to be done before it's possible.
Okay. Any more questions or comments? No, so let's thank Nicola again. Thank you.